Alright, for today we're going to take a closer look at isosceles and equilateral triangles. On an isosceles triangle, you have two sides that are congruent. Those two sides are called the legs. You have an angle where the sides intersect is called the vertex angle. In this example on the right, we have the vertex being B. The side across from the vertex is the base, and then the two angles that touch the base are called your base angles. Alright, there are two theorems associated with isosceles triangles. The first is the isosceles triangle theorem that says if two sides of a triangle are congruent, then the angles opposite those two sides are congruent. For this example, since we have segment AB being congruent to segment BC, we have angles 2 being congruent to angle 3. Again, because those are the angles across from the legs. This theorem also works in reverse using the converse of the isosceles triangle theorem, where it says if you have two angles that are congruent in a triangle, then the sides have to be congruent. So since I know on this one that if I said angle 2 was congruent to angle 3, then segment AB would have to be congruent to segment BC. So, to recap, if two sides of a triangle are congruent, the angles across from those sides have to be congruent to each other. And if two angles of a triangle are congruent, the sides across from them have to be congruent to each other. So looking at example 1, we have that these two sides, KL and JK, are congruent. So that means that the angles across from those sides have to be congruent to each other, which means angle J must be 68 degrees. To find angle K, we would have to do 68 plus 68, which gives us 136, and then subtract that from 180, which gives us that the other angle would be 44 degrees. In example 4, we have two sides that are congruent, which would mean that the angles across from them have to be congruent to each other. We do not have values for it, but wants to find each of the variables. Since these two have to be congruent to each other, that means that 5x plus 9 equals to 8x minus 30. We have to solve for x, so subtract 5x from both sides. Ends up giving us 9 equals to 3x minus 30. Add 30 to both sides. And we get 39 equals to 3x. Divide by 3. And ends up giving us that 13 equals to x. On number 6, we have these two angles being congruent, which would mean that the sides across are congruent. So we can set these equal. 15x plus 7 equals to 23x minus 17. Subtract 15x from both sides. Ends up giving me 7 equals to 8x minus 17. Then we're going to add 17 to both sides. Ends up giving us 24 equals to 8x. Divide by 8. And 3 equals to x. Number 8, it says in triangle RST, segment RT is congruent to segment ST. Measure of angle R is 9x plus 2. Measure of angle S is 13x minus 18. And measure of angle T is 17x plus 1. Find x and then find the measure of each angle. So I ended up drawing this picture here. I just drew a triangle, labeled the sides, or the angles R, S, and T, and then labeled the angles with the values that they gave us. I then marked RT to be congruent to ST by using the tick marks. Since these are congruent, that means that the angles across have to be congruent. So the values that I'm going to use to set equal will be 9x plus 2 equals to 13x minus 18. So then I end up solving this problem. Subtract 9x from both sides. We get 2 equals to 4x minus 18. Then add 18. And 20 equals to 4x. Next step is to divide by 4. So 20 equals to 4x divided by 4 ends up giving me that 5 equals to x. Then I'm going to plug that into each of these angles. So for r, that would be 9 times 5, which is 45, plus 2, which gives me 47. For s, it would be 13 times 5, which is 65, minus 18, which, as I showed before, since those two angles are supposed to be congruent, is also 47. Now I can also plug into the last one. 17 times 5 plus 1 gives you 86. You do not necessarily have to plug into the last one, because once you had the other two, you could have just added them up and subtracted from 180. Alright, the same rule for isosceles triangles works for equilateral triangles as well, except instead of just having two angles congruent, you have all three angles congruent. If all three angles are congruent, that means that all three sides have to be congruent. So for this one, AB would be congruent to AC, which is also congruent to BC. And it works in the same way in reverse. If you know that all three sides are congruent, then all three angles must be congruent. So angle A is congruent to angle B, which is congruent to angle C. Alright, now let's look at a couple of examples with this one as well. So number 11. Again, if they're all going to be the same, we've talked about this. If we have these as 60, we can do 60 plus 60, which gives you 120. 180 minus 120 tells me that the last angle is 60 as well. So now all three angles are 60 degrees, which means that all three sides have to be congruent. So if we have that AB is 9 feet, that means that every other side is also going to be 9 feet. Alright, also looking at number 13, it tells me that this is an equilateral triangle, so we have to solve for x and y. First off, solving for x, we have that as an angle. So in an equilateral triangle, all angles will always be 60 degrees. So that would be 60 equals to 7x minus 3. Add 3 to both sides. And we get 63 equals to 7x. Divide by 7. And 9 equals to x. To solve for y, we just pick one of the two of the sides to work with. Does not matter which one. I'm going to go with 9y plus 1 and 11y minus 23. Subtract 9y from both sides. It gives me 1 equals to 2y minus 23. Add 23 to both sides. And 24 equals to 2y. Divide by 2. And we get that 12 equals to y.